this is the review for 115 and 150. Number one, we know that f of 3 is equal to 6, which means we have the point 36 on our graph, and we want to find another value. So this is symmetric according to the origin. Think about 3, 6 would be right there, maybe. Across the origin would be down here, which would be -3, -6. Okay, so the answer that we have would be f of -3 would equal -6. Okay. Part B, with respect to the y-axis. Okay, so we still have to start with that same point, 3, 6. And if I take that and reflect it across the y-axis there, that becomes the point -3, 6. We know that f of -3 is equal to 6. Okay, part C, when we're still starting with f of 3 is equal to 6, we have to think, when does f of -x equal to negative f of x? Okay, when it's equal to the opposite of that, we know that it is an odd function, and odd functions are reflected across the origin. Okay, so we're really doing the same as part A. So taking that 3, 6 across the origin becomes that. Whoop, let me write that very well. There we go. Okay, and D, we're starting with the point 3, 6. Okay, and it says that f of -x is equal to negative, let's see, is equal to f of x. Okay, so if it's equal to f of x equal to the original one, we know that it's then an even function. And if it's an even function, we also know that's reflected across the y-axis. So if you think about across that 3, 6, across the y-axis, same as part B up there, we have the point f of 3 is equal to -3, equal to 6. Okay, so that's number one. Number two, I'm going to zoom this out so you don't lose you here. Okay, number two, we want to match these up. Okay, so 7 units to the left. No, okay, we'll just go this way. So if it's -7 on the inside, it actually goes to the right. So part B. And at the end, -7 moves it down. So down 7. And 7 in the front is a stretch. Okay, now it actually says horizontal versus vertical stretch. I've only talked about vertical stretches. So that is a vertical stretch. Okay, +7 on the inside actually moves left. Okay. Okay, and I didn't talk about this much, but if it's on the inside, it's a horizontal stretch. Okay, number 3. Okay, we also want to match them up here with the sketches. Okay. Okay, so let's look at A. We know it's a parabola that opens +2, so up 2. So here's a parabola opening up 2. Part B, x squared -2, so it's a parabola. -2 is down 2. A. C is x plus 2 squared, so that's moving to the left 2. Left 2. Part G. Part D, -2 makes it actually move to the right 2. Moving to the right 2, we have C. E, 2x squared is a horizontal stretch, which makes it skinnier than normal. Okay, so skinnier than normal looks like F there. F, the negative x squared, the negative, instead of opening up, it's reflecting over the x-axis, so it's opening down. G is doing two things, going up 1 and right 2. Up 1 and right 2, it's right there with H. And H here goes up 1 and left 2. So up 1 and left 2 for E. Okay, number 4, we want to sketch these all by hand here. Notice they're all absolute values. So if they're absolute values, you know they're going to be B's. So part A, with the 4 in the back, that shifts it up 4. Part B, plus 4 on the inside, moves it left 4. Part C, minus 4 on the inside, moves it right 4. D, okay, D is doing two things, going up, down 4, and plus 2 makes it move left 2, so there's my vertex, and it's still opening up. E, doing three things here. So plus 4 shifts it up 4, minus 2 shifts it right 2, and negative means it's going to open down, reflected across the x-axis. Okay, number 5, we want to tell how it's moving and then give the equation for it. Okay, so 5a, we can say it's going up 3 and left 1, and it's reflected over the x. Okay, so our equation would be y equals, we know it's absolute value, and if it's up 3, we put plus 3 in the end. If it's left 1, we have plus 1 here, reflected over the x, makes it negative. Okay, for b, okay, now this is, the parent function is a square root. Okay, so and that square root is going up 2, left 4, and usually it's opening up, so it's opening down, so once again, reflecting over the x. So my equation is going to be, you know, it's a square root function, so since it's going up 2, we have plus 2 in the end, going left 4, so it's plus 4 on the inside, reflected over the x makes it negative. Okay, 5c. Once again, it's a square root function. Going down 4. Going left 4. Okay, so our equation would be square root function again. Down 4 is minus 4 on the end. And the other one, x plus 4, since it went left. Now the 2 here, usually it goes up and goes right here through 1. Okay, and goes up from there, and you can see it's up 2, so it's actually 2 times that. If you didn't get that, that's not horrible, because that's hard to see. Okay, in part D, okay, we have a square root function. Sorry, not square root, we have an absolute value function. And that moved down 1, moved right 2, and it's wider, right? So if it's wider, it's a compression. So you have that goes up 1 over 2 sort of idea. Okay, my equation is in absolute value. It went down 1, it went right 2, and it compressed by a factor of 1/2. Okay, so that's through 5. Okay, so number 6, we have these two functions here. We want to know this g of x function is a result of doing what to this? Okay, so if you're thinking about where it moves up and down, we know this f of x is moving, okay, take a point, moves up 2. So you would say that the g of x is equal to the f of x plus 2. So if we take this function, add 2 to everything, it shifts up. Okay? Now, since it's linear, you can also kind of think of it as going side to side. So if we're thinking about the side-to-side part of it, take a point, 1, 2, 3, 4. It's going 4 to the left. So if it's going 4 to the left, it'd be like x plus 4 there. If it was going to the right, we have an x minus 4 there. Okay? That's 1 through 6. Number 9. Okay, we want to complete the table. A, if it's an even function. And then for B, if it's an odd function. Okay, now if you remember, if it's an even function, even functions are across the y-axis. Okay, so think through this here visually. So if I'm at negative 3, 4, reflected across your y-axis would be at the point 3, 4. If I'm at negative 2, negative 6, reflected across the y-axis would be 2, negative 6. And if I'm at negative 1, 5, reflected across it becomes 1, 5. Okay? And an odd function, is across the origin. And visually, I'm at negative 3, 4. Across the origin becomes the point 3, negative 4. And that negative 2, negative 6, across the origin becomes 2, positive 6. And if I'm at negative 1, 5, across the origin becomes 1, negative 5. Okay, so that's number 9. Okay, page 150, number 1, asking you to solve these 3. Remember, with absolute value, we set up those 2 equations. We have that's equal to 4. We have it equal to negative 4. So to solve that, you subtract your 2 over, multiply by 2, subtract your 2 over, and multiply by 2. Okay, so I have the 2 answers of 4 and negative 12. You can plug them in and see if they work as well. For part B, 1 is exactly like it is. The other one, switch the sign and when you make it negative. Okay, and remember, it's a greater than, it's an or statement. Okay, so when we solve this, 1 half x, subtract your 2, and multiply by 2 gives you 4. Subtract your 2, and multiply by 2 gives you negative 12. Okay, so now we got to graph this. So we have negative 12 is my lower number, 4 is my upper number. Has to be less than negative 12. X is greater than 4. Okay, so we have those answers there. Since it's an or statement, it's these numbers or these numbers. So we could say it goes from negative infinity to negative 12. And then also from 4 to infinity. Okay, part C. Once again, we're going to set up those 2 equations. Switch the sign when you make it negative. Solve them. Okay, and since this is a less than, I know it's an and statement. So when I look at my graph, it has to be greater than or equal to negative 12. Has to be less than or equal to 4. So what numbers is it true for this one and for this one? Has to be true for both, or all those numbers in between? I know it's the numbers from negative 12 to 4. Okay. The other one you had to do there was number 2. Okay, you're given this graph. You want to sketch the absolute value of this graph. Okay, so that graph looks like this. Okay, and if you remember, absolute value just makes it positive if you have negative numbers down here. So it looks like, so this part would still stay the same. This part here would have to reflect up though. Okay, so no negatives. Okay, that is that homework assignment.